Hey guys, welcome to RC Video Reviews. We're doing a little bit of an off-cycle PilotJam due to work constraints and trying to get some flying done and getting the models done. It's been a little hectic around here. So what we're gonna do, this is not gonna be a traditional PilotJam. This is gonna be, I'm gonna call this the Avanti special. We're gonna spend a lot of time talking about the Avanti because you know what? It's worth it. Man, that plane is really something else. It's a nice plane. That's all I can say. It's a nice plane. So we're going to spend time talking about what happened with that plane tonight. And before we get into it, I've got a very good clip from Dave. Dave, it's a montage of the build. So a lot of you guys have asked for a build video. You're like, hey, can you do a build video? And it's, build videos. I give a lot of respect to the guys that actually put those videos out because it's challenging to do that. You're trying to build the plane in the first place, and then you have to get the camera set up right and working, and you got to talk about what's going on. And, right when you're trying to glue something together, you got to change the camera angle. I don't know how they do it. I've tried a couple of times, and it's not for me. But anyway, Dave took some, as he went along, he took, I think it was just a couple. I think there were, a handful, about 49 different clips he sent me. So Dave was keeping me informed, which I greatly appreciate, man. But 49 different clips. It was absolutely nuts. So I edited them, I stitched them together, put a little music to them, and we'll watch Dave's video. He did a great job. So anyway, yeah, the Avanti done and maidened, and we're up and running with that. And I'm really happy that we got that underway. And I'm not gonna lie, man, that video that airplane kind of had me a little sketched out, just a little bit, not a lot, but it's one of these airplanes you just really don't want to make a mistake. It's not like a foamy or a cheapy. If you crash, whatever, do a repair and get it back up and running. It's not a basher. And even some of the 3D planes, you're like, well, if I crash it, at least I was trying something crazy and I can get some spares and put it back together, But this plane, man, it was something else. In the build process, I think he put about 2 weeks into it. Well, I have so many planes I've built overnight. Dave put some time into this one, I can tell you that. And there's some complexity to it, which I'll cover. I'm going to talk a little bit about the complexity. But anyway, the first video was the best airplane I own, the 85-inch Extreme Flight Laser. That thing, all I can say is that's my Huckleberry, man. That's all I can say about it. The laser is just an amazing airplane. It's my favorite. It's my favorite all-time airframe, the Extreme Flight Laser. It is just hands down my favorite. And having the 85-inch makes me really happy. It's fun to fly. I had a great time putting it in the air. And, just like all the others I've had, the 60, 67, 74, now 85. Just like all the others, it flew quite well, exceptionally well for me. It just works. And then the next video was the Sebart 90mm mini Avanti. They call that one a mini, and that was the maiden flight, and then of course the PilotJam. So yeah, it's been a little soft on the video production, but hopefully the videos have been worth the wait. I can tell you that it was a big month, guys. I mean, if you look back in the rearview mirror, an 85-inch laser and a 90mm Avanti, all in the same period of time. It was a big month in terms of hardware. So we did get some content out there. I'm really happy about that. And let's get on with the video. So without further delay, that's the week in review. I'm going to get into the build. I'm going to check comments too while the video's going. So if you guys have anything you want to ask about during the video, I'll be able to do that, because I'm just going to play a video that I cut together from Dave's montage. So feel free to ask comments, ask questions, and I'll do what I can to address them. And then when we come back from the video, we can talk a little bit more about it. Before I hit the video, Sir Trumpington got in first tonight. That's a change. Johnny Stansel got in second, Mitch Gantry third, and Ramble Flight Ken, hello from Arizona. You guys are quiet tonight too, so how about that? Anyway, don't forget to say hi in the chat when you pop in, and let's take a look at the Avanti build montage from Dave.
So we're starting the assembly of this guy just now, inspecting stuff. It's a beautiful airplane. Wow, it is nice. Holy cow. Starting the assembly of it. So doing like an inspection, inventory, quality control a little bit, make sure everything is there and good. There you go. And yeah, we have the nice new brakes. Those suckers are heavy. Alright, so there you go. We got all the stuff. It's all laid out and organized so we can pick it up as we go. I like to do this with these. Separate them, make sure I got it all, which, as a matter of fact, I am missing the screws that go to these nuts. But they should be around here. Well, I'll look for them. If not, we'll get some. Not a problem. Alright, well, look at the wire spaghetti coming out of this thing. Got servos, aileron, flaps, retract gear, and brakes. I am installing the brakes right this minute. Right there. This is what it's going to look like. This one is done. Other than I managed to get that arm, servo arm hidden. That I like. I like that. And that's what it's going to look like. Everything is out of the way. And then, yeah, there you go. There's the spaghetti. Nice. Alrighty, so the wings are done other than the fences. The fences are not there yet. I decided to leave the arm on the, these are the smaller arms that come with the servos. No problem there. Everything hooked up. Everything is hooked up per the book. And I decided to leave the extra arm on there, not cut it off in this case. Because I've kicked my butt several times cutting it off. I want to use it somewhere else, and that's where it would line up. So it doesn't hurt to have it there, I guess. So that was executive decision. I guess if John wants it off, he can cut it off. Anyways, I don't think so. Or whatever, you know, it's his hobby, his money. My hobby, his money. Okay, there's the flaps. I was able to hide the way it's kind of intended. It all fits in there perfectly. No cutting, no sanding, no nothing. It fits in there perfect. It almost didn't make it. I almost had to use a longer arm, but that is good right there. It is beautiful. They work really good. And here is the landing gear. So this is what we got. I do not use here. I don't use, sorry about the hand here. I don't use a zip tie because zip ties cut the wires. I used to do this for a living, the wiring thing. Low voltage, high voltage. Anyways, I was an electronic technician. Animation and automation. But yeah, that is a string. And it's much softer than a zip tie. The zip tie looked kind of dumb. So let's see how it's going to behave when it springs. There you go. There you go. It's harder to film than it is to build the stupid thing. Alright, so that's that. Yeah, I keep this far. By the way, you notice there's no tools on the side I'm working. All the tools are separated by something. Because every time you put your tools here, you'll put the wing or anything you're working right on top of the tool. And now you have a beautiful tool imprint on your fiberglass, wood, monocoat, whatever it is that you're using. So here we go. Just to see how that goes in and out. How the wire folds nicely. Okay. There we go, and the cover fits perfect. I'm gonna bring it back out again. Perfect. Let me turn it around, see if we can see it from this side. Yeah, and you can see there's no kinks. There is no kinks at all. Okay, and actually we can be kind of inspecting the thing every time, you know, just keep an eye on it because that's gonna, either you put it on the back or you put it in the front, you're gonna have a bend anyways. It just tucks in, it folds in nicely. I like it. All right, one more from this angle. And there she goes. Beautiful. And that is what I gotta remove to get it to fit. See the lines right there? I'll just get my Dremel with a cutting disc and knock that out. Oh, the tube, when I stick this guy, the carbon spar, It just kind of puts a little bit of a dent on the thrust tube, so I'm not going to worry about that. That's good right there. But yeah, we had some. Oh, this was very loose on both sides, really, really loose. In this case, I didn't use paint. I put some tape on both sides and stuck it in until it was hard, and that is hard. And I know John's not going to be taking this apart, so that's why I did it that way. If this was going to be coming apart all the time, then I would have probably painted and sanded and painted. But this, and if it was mine, I wouldn't take that tail apart either. I mean, it's small enough. It's just about here. So there you go. Yeah, watch it. Very good, very nice, beautiful. But you just gotta watch them. You know, little details like that. Trucking along. Oh, I'm still gonna be working on it for a while. Had some, had to work on the back. I knew that tube was loose, so I had to work on that and tighten it up. Took a while. Okay, that's what the big enormous arms look like. Good, great. All right, this I'm still working on. But I installed the EDF, which I had a heck of a time trying to find screws for it, but I did. I know I got them, they're just everywhere. Torque stripe, I did not put Loctite. Loctite on that cone. That cone screws in reverse thread. It was funny, I was for about an hour and a half trying to screw it in the wrong direction. Till I realized, you know what, maybe it's reverse thread, and it took me about 1/10 of a second. Hey, okay, so a little bit of torque stripe just to make sure it's not moving, and it's got torque stripe in the back one too, but that is hard to get to. And I was getting ready to install the ESC right under that plate. It does not fit. It doesn't go. Okay, so change of plans there. And then the bullet connectors on this thing are huge, and the ones on the ESC were beautiful, but okay, that's kind of how this is going to fit here. The battery somewhat goes there, somewhat. ESC is going to have to go on top here, right there on top. And we got a little bit of room here to play with. And so yeah, the ESC had some beautiful connectors on it, very well, and I had to take them off and solder these humongous ones that come with the EDF. Because these are bigger, so they didn't need to be bigger, but I just changed the ESC connectors, not the EDF connectors. Remember my camera holder from RCVR 3D? 3D RCVR. What is this 3D printing? Well, this one is too. That one is from 3D RCVR. That's the solder holder. Got two different gauges of solder, one in one direction and the other one in the other direction. That one doesn't unwind the other one. When you pull this one, and it kind of pulls on this one, it actually winds it back up. Yeah. RCVR 3D. There you go. RCVR 3D. RCVR 3D. There's one. Beautiful. Holding phones, camera, whatever. Then there was a solder holder, the phone holder. That's also a phone holder, of course. And this is the connector holder. I just did the soldering on the connectors for that ESC. And it just makes it so much easier. There you go. 3D RCVR. Nice. I'm going to need commission for this, John. So we have our two servo for the elevators and our two power feeds for our remote. Not secondary. For our other receiver, because it's not secondary. Anything handled in the elevator is not secondary. That's pretty freaking primary to me. Anyway, that receiver is going to go back here. I thought up in the top, but I may put it down here for airflow. So we'll see. And that'll be inside there. All right. And then talk about wire spaghetti. Wow. My goodness, look at that thing. I don't even know what's what anymore. Oh, check it out. And that is the CNHL battery. That was the channel. All right, so that's that. Very nice of them. That's a heck of a battery. And look at all the spaghetti wires, and I still have to put all of those in yet. All right, well, we're coming along. I can't wait for John to get the bigger one. Yeah. Okay. So this is what it's going to look like. Obviously this goes into the brake circuit. That wire goes down and under and out here, of course. No, actually not. That's gonna go onto a Y. That's gonna feed on this side. That goes onto a Y that plugs in here. And one of them goes out on this wire. The other one in here, because that's one power. Then the other power is channel 3, which goes onto a Y and feeds this other wire that sends power back over there. Okay, bud, I'm trying my best, but it's Thursday at 5 o'clock in the afternoon. I've been working on this until late. I'll do my best. But this is not the end of this. I still got to secure them, tidy them up, but at least now I got this far, which it took a while to get this far. Oh, yeah. It's going to look really nice. There's wires like, wow, like I never seen before. So, this is the diagram. It's like a block diagram of the main system. This doesn't include the subsystems like brakes, retrack. It just includes the signal to it. If I draw the whole thing, it'll look like that other drawing I sent you. All right, man. Well, I'm working on it, and I will continue to try my best. But I still got to make these harnesses and these diodes things and connect them and shove them down the bottom. And we got to program the servos. We're going to do that together. All right. Well, you already saw this real quick. That's like a global diagram. Then I have to do the diagram of the power supplies, redundancy power supplies. Make sure it feeds everything from every direction without shorting anything out. Here you go. And for the harnesses here to plug them in, so each one of the power supplies feeds both receivers at the same time. Each one of them feeds both receivers. Then I have to make some harnesses with the diodes. So there's the diagram so I can keep myself straight for the harnesses. Right there. It's only one diagram because they're both the same. But I got the addressing of the connectors. That's for harness 1, that's for harness 2. There you go. Oh, there's the diodes. So, they're good diodes. That's a 10 amp diode. And the reverse bias voltage, I think it's nothing. Or if it is something, it's totally insignificant. That's a silicone diode, so that'll drop the voltage by 0.7 volts, 700 millivolts. So on a 6-volt power supply, 6-volt system, which is what we're using because of the servos, we would have 5.3 volts, which would be fine. But John likes it higher, so, and I agree. These are Schottky diodes. The silicone ones we said are 0.7 volts. These are 0.3 to 0.4 volts drop. The voltage drop is 300 to 400 millivolts. They're a little smaller, but they're the same quality. They're good quality diodes, and these are 9 amps. But since we're using 2, so yeah, we got 18 amps, so that should be sufficient. So there you go. More power, like Tim Allen. Okay. All right, hasta la vista. All right, look at her. Nice. Got the fences on, side force generators, whatever you want to call them on a jet. Like we said before, side force generators on the ends on the 3D planes, fences on the F3A when they're in the middle of the wing, whatever. Your hobby, your money, your word. So okay, so we got lots of wires under here, lots of them. This is not done, but it's now close to looking like it's going to look like. So we have our feed here, and then we got an extra wire that we're going to run off of here to feed our BEC external, which is going to come out and feed this receiver and the receiver in the back. But it's going to have a diode right out of it, so we don't get no power back. One diode, just power out. Then from the ESC, we are going to be getting power, obviously. And then we're going to get a diode. And we're gonna get one comes here to this receiver, the other one goes to the receiver in the back. Okay, and so this is the diagram that I had to make up because I couldn't keep it straight in my head. There's the diagram, the two receiver, there's receiver number one, and it's kind of a simplified diagram, and it's a diagram of the whole system, of the main flight system, not the subsystems. Subsystems meaning the dual power supply, the brake, the retracts, none of that, just signals. Power in and signals. So there you go. We're using every channel on that 8-channel receiver, including the battery, as per a feed to our secondary receiver, which is the one in the tail. There you go. And there's the description of what we are using on each receiver. You know, channel 1 is ailerons, 2 is going to be flap 1. Oh, channel 1 is aileron 1, flap, da-da-da-da-da. You get the thing. Flap, it's all labeled. All right, and then, so that is the flight system. Now here is the dual power supply system. And all these wires are in there, believe it or not. Now we got to hook all this and make it organized and make it make sense. Yeah, basically, we got the main battery, which is here, you know, the main battery. And we're going to feed the BEC, which is going to power the brakes before the diode. Then, here's got we diode, and we're going to power both receivers. It's hooked up to this one and also to this one. Okay, and then the ESC, well, that's the ESC. I got these BEC. I wish I would have drawn them backwards, but it's the same thing. So here's the ESC. That's the signal for the throttle. There's your diode. It feeds this one right there, and it also feeds this other receiver. So you feed both of them from both of them. This one feeds both, and this one feeds both. In case you lose one of the power sources, you got full redundancy of the whole system. And the diodes are so we don't feed power backwards into each other. You know, when it's a battery, is okay because they're exactly the same if the batteries are the same. But these two are not going to put out exactly the same voltage. And I'm pretty sure they're not voltage protected, and we're not going to find out. So there you go. Now, that's what I got to do now. Build that circuit, hook up all that circuit. I got the components all in there. I just got to plug them in. And that's it. That'll be another day or two, probably. Looking nice. Look how nice the servo and all that fit in there. We got a receiver. All of the wires come up here. Oh, yeah, let me show you. These are the two wires that feed the receiver. Right there. The receiver in the back. These two. We have one power, two powers. One comes from the auxiliary of the BEC, the second wire that has power, like the program or data, whatever, but that has power. So that's one of these. The other one from the ESC, the other one's going to come from the BEC from the receiver. Okay. Then rudder and two elevators. Rudder right in the middle. The elevators on the side, and power all the way on the outside. So that makes that power bus equal, and it actually circulates around the whole thing back and forth. So it is a redundancy. All right, this is the third try, and this one did work now. So there it is, and we stick it up like that. I was putting it in this way, but I changed my mind. I want to put it in that way. We'll see, because the wires, it makes the wires a little longer in the front. And once that's in, servo goes in. The servo itself holds itself because there's no place to put screws here at all. It can make the place if necessary, but I had to make the place down there for the screws, if you can see. Okay, wait a minute. If you can see, I had to put some wood, whatever. Anyways, very complicated solution. But it's nice, it's cool, it's it's something that can be done, and we needed it here, and great. We'll see how it works. There's the rudder. So that thing's supposed to go up in there. Like, I'm gonna need both hands for this. Like that. And we kind of put a little bend on the credit card. That goes in there. Oops. Like so. And then we push it. Boom. Get it up and out of the way. You gotta get it out of the way. Back that way. Okay. Alright, I have to do this and I'll show you later. I only have a hand and a half, and I'm using already the one, so antenna one goes that way. It couldn't go down. There's carbon down in there, and then they wouldn't fit anyways. Alright, here's the other one on top. Right under there. So they're at 90 degrees. And yeah, that's it. Here's your space for your voltage converter thing, your telemetry, which I was going to remove it from the laser that I got here, but that sucker stuck in there really good. So what I'll do is I'll take the Velcro and we'll just put it on the new one, on the one you got over there, plug it in, and it'll be done. Okay, your brakes. No, that is the retract sequencer. And BEC for flight control system. Yeah, the BEC we're waiting on goes here, and I just got to hook that up. All right, man, look at that. Ooh, wax in, wax out. Ooh, look at that beauty. Nice. There's a whole bunch of shit around it, but it'd be better if this was outside. But oh well, there you go. This is so cool. And the oleos on this thing, look, I just barely touched that nose, look. Not only that, check these in the back. Check this, just barely touch it. Actually, I'm not doing anything. Let me lift the weight of the wing a little bit. Look at that, and look at that. Ooh, I should have put some music. Na 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 na. Alright, man, yeah, it is a gorgeous machine. Nice, nice, nice. Alright, the final touches. We finally got the brake BEC, because that's going to run on its own BEC. The brake power for the solenoids. And just the final touches here. Had to solder that inside the airplane because it was all installed already, so I'm not going to take it apart to solder it, so took a little precautions though. A little paper and towels and newspaper, whatever. Alright, nice, 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 nice. So after that, I just got to throw some straps here and there. If I am going to throw straps, I may, yeah, the battery ones at least, because all the other stuff is very secure. Alright, just showing you this. This is the last thing I'm doing, and the plane is done. Woohoo! Oh no! Look! It's empty! No Avanti! Oh no! So we start.
That's it. That's the end of the montage. I'll tell you, Dave, I think Dave had some fun building that plane, and he certainly did a great job. I wanted to show a couple of last pictures so you guys could see what the final outcome was. So there's a look of the cockpit at the end of the day, and you can see we put a second BEC in there. I'll talk about that in just a minute, and we'll also cover that actually in the build. There's a standalone build video. And so one BEC on the port side, one on the starboard side. The one on the port side that's marked with an R, that goes to the flight control systems. So you have the BEC on the ESC, and you have the standalone BEC on the port side. Those are the two supplying power to the receiver and servos and the gear and everything else. And then the one on the starboard side is for the brakes. And the reason we had to do that was because you could only go as high as 6 volts for the servos. The servos had a limit of 6 volts. But the minimum input voltage for the brake controller was 7.4 volts. And we were using an 8S battery. So the only way that we could figure out to do that without doing something like putting a diode in line and feeding a separate line from the original BEC to the brake controller, that wouldn't even work. We would have had to put a diode. We'd had to set the voltage to 8.4, feed the brake controller, and then use a resistor to bring the voltage down. And I just didn't want to go through that, so we stuck another BEC in there. That's what we did, and at the end of the day, it worked out. So very, very complex build. Now, during the video, a couple of guys were, and in the comments, other people asked about a gyro. And I'm not, like, the main reason there's no gyro in it was simply time. We were already very pressed for time. And as you can tell in this wiring setup, it was already a fairly complex arrangement. And I think if I would have given Dave a gyro and said, oh, by the way, stick the gyro in there, he would have said, no, man. There would have been a rebellion. I think Dave would have said, do it yourself. So anyway, that was one reason. And the other reason was that recently I lost a plane. We think it was due to the gyro. And it was because it was a 3D plane. And I think what happened was I was thrashing the plane pretty hard. And I think the current going through the gyro is probably too much because the servos are being fed from the gyro. And they're really not designed for that. That's not what they're designed for. So now my theory is real simple. I know how to handle that. And that's from going forward, I'll use power to the servos from a PDB and signal from the gyro. So you can just do signal out on the gyro. That's no problem. And let something else give power to the servos. So for a more advanced build, something that's got higher current demand, that's probably what I would do. I don't think it'll be a problem on the Avanti to put a gyro in line like you would with most any other setup, because the D85 MGs just are not really high current draw servos. So I don't think they would be a problem. But anyway, there's the last reason I would say no gyro is because even though I did a dual RX setup in this one, my other theory was, let's get the plane up in the air and fly it around for a while first and make sure everything else works first. And then after I'm very comfortable with everything else, the dual BCs, the ER8, the dual RX setup, then we'll add one more thing that could possibly fail, and that would be the gyro. So there were a lot of good reasons we didn't use gyro. I know people like the idea of gyros and jets, and so do I. They definitely clean them up a little bit, but we'll get to that. We'll get to that. So anyway, there's the cockpit, and then the last one I'll give you is the EDF. There's a look at the EDF. That's a JP Hobby 8S 90mm. And again, Dave, all I can say, high praise for Dave, man. He did such an amazing job putting that plane together. It looks really, really good. He did a great job. And then okay, so we're gonna talk. That's the build. Let's talk a little bit. Not the Maiden. I don't want to do the Maiden. I want to talk a little bit about the setup. No, let's talk about the Maiden. Let's do that. Let's take a break on the build stuff. Let's talk a little bit about the Maiden. So I was very thorough in the video explaining my rationale for the voltage. And I know, I even put a graph. I pulled the graph down off the radio. I pulled the logs and graphed it. And everything that I expected was true. We did see some voltage sag below 3.75. And that happened, I have the 6-second delay built in, so it's not just one peak below 375 and it goes off. It has to be there for 6 seconds. And then when it stops sagging, it goes off. And we hit 3 of those, and then, or I think 2 of them on the maiden, and we landed it. And that was by design. I did that by design because first off, brand new battery, brand new plane. And I really just didn't want to take any chances with this one at all. And I'd never landed the plane before. I didn't have any idea how I was going to handle landing. We were also dealing with 25-mile-an-hour winds. So like everything was stacked against us on that one. So I decided to go very conservative on the power. And after we got it on the bench, it rested at 3.85. So the first thing I did on the second flight was bring it down another 5 100ths. So 3.7. It was 30 volts, and then I dropped it down to 29.6, so 3.7. And I'll keep dropping it down. As long as it rebounds back to 385 or higher, I'm going to keep bringing it down. I'll keep bringing it down. We'll get the flight time out of it. I'm not worried about that. I'm confident we should get about 4 minutes out of this plane. But like I said, early on, I just wanted to be hyper conservative, and so that's what we did. Now let's talk a little bit about the setup. So on the setup, the dual receiver thing, there's really one reason that I did the dual receiver thing, and that was for you guys. I did that. I asked Dave to do it for you guys. Oh, and you know what? Before I get the radio, I do want to show you guys this one. So real quick, let's take a look at this is Dave's diagram. Oh, by the way, he did something hilarious. This is when he started. This was his diagram when he first started. Isn't that funny? That was a a little bonus material he left me. But anyway, here's a quick look at the diagram. So the RX, the first RX, this is the ER8. That's got aileron 1, flap 1, the throttle, the nose wheel, the retracts, the brakes, flap 2, and aileron 2. So that's 8. Now, yes, you can Y stuff together. You can Y the ailerons together. You can Y the flaps together. You can even Y the elevators together if you want to. You can do that, right? You could do that. So no arguments there. I'm not arguing about that. You could do it. But if you did individual controls, you can see how fast you chew up 8 ports on an ER8. Then in the back, I thought about it and I said, you know, there's been a case in the past where I thought about doing a dual RX setup and it was on a twin engine plane. So rather than running ESC wires all over the place, I thought about putting, you know, an RX in one cell and an RX in another cell and feeding the motor directly, you know, the ESC right there. I just thought it'd be kind of cool to try that. And the only real thing, so this is Express LRS, and the only thing you really have to do is on receiver 1, you bind it using a binding phrase. So you just do a binding phrase. And that binding phrase, let's just say it's X, Y, Z, just to keep it simple, okay? So when you do that, you bind your radio to your receiver using a binding phrase. Then you do the same thing with this one. The same binding phrase goes on this one. You use X, Y, Z. And what will happen is you got to remember the transmitter, except for telemetry, the transmitter doesn't have any idea what's going on the plane. Like the transmitter just throwing it out there, right? It's the receiver that's picking it up. So with that binding phrase in effect, what happens is the receiver picks up the controls from the transmitter. It picks up the signal from the transmitter, right? But so does this one. Now these two, the only problem you have is the EdgeTX radio, the Radio Master TX16S using EdgeTX. You can't have telemetry stream. So this is telemetry stream 1 and this is telem 2, right? You can't, they both are going to, this is why I said that this is the one thing the transmitter does know from the model, and that's the telemetry stream. So that is going back toward the ground station, right? So you got telemetry stream 1 and telemetry stream 2, and they're both going back to your radio, okay? So what you have to do is you have to turn off telemetry on one of them. You just turn it off. And Express LRS does provide for that. So in the receiver number 2, which is in the tail, we turned off telemetry and we left telemetry on here and it worked perfectly. The only other thing that we had to do is a remap. You notice this has got channels 1, 2, 3, 4, 5, 6, okay? And you have 1, 2, 3, 4, 5, 6, 7, 8 up here. So what do you do about that? Well, it's simple. You just, all I did was just did +10. So I remapped, I went in and remapped every channel. So this RX, listen on pin 1, it was listening for input channel 10. Or sorry, 11. And then this one was looking for 12, and this one was looking for 13, and so on, right? All the way to the end. So when you look at the radio setup, the elevator and rudder, they're using high numbers like 12, 13, whatever. You know, they're using the high values. And these are using the low values. And one other thing to keep in mind is that ridiculous arming thing on pin 5. You have to remap that. So on the front receiver, we go 1, 2, 3, 6, 7, 8, 9. Okay? And then here we go 11, 12, 13, 14, 15, 16, 17. Okay? So that's it. That's the radio setup, and it worked like a champ. And one other question. This leads me into the next phase. So Sir Trumpington in the chat during the video, he said, "Why did you use 100 hertz?" And the reason we did that, I'll show you. When we were setting things up, I was really I've used these EPW6 receivers tons. I've got them. I've been using them forever, long time, years. And I've never had a problem with them that I know of. I've never had a problem with them that I know of. And when we were setting up the D85 MG servos from High Tech, Dave brought the plane over after he got everything done. And he brings the plane over. We connect the servos. We power everything up. And when we did that, battery would help. So it'll bind here in just a second. This has got my binding phrase on it. So when that goes solid, it'll be bound. It'll take a little longer. There it goes. Okay. So right now, I don't know if you can see it, but that thing is twitching. It's twitching. It's going back and forth, back and forth. And when you hook up a control surface to it like an elevator, you can see it. The elevator was just twitching. And I know I would, like when I got ready for the video tonight, I tried to see if I could get this to to be visible, and you can't, but believe me, it is. I can feel it. And when you hook up a control surface, you could see the surface just doing that. It wasn't dramatic. It wasn't a lot. It wasn't a whole great big movement, but it was enough where I was like, I really just don't like that. Now, and it wasn't the typical digital chatter that you get on servos. The control surfaces were actually moving. And I thought, nope, I don't like that. So to answer Sir Trumpington's call, what we did was, one of the first things I did was say, okay, let's go into Express LRS and just set everything to a common frequency with no divisors. So I used 100 hertz over the air, and on the receiver, I used 100 hertz on the PWM output. And that way, I figured there would be no clock divisor issues potentially causing that chatter. It was a troubleshooting effort. So now that's we tracked it down to the receiver, I'll probably go ahead and upgrade and maybe use the higher over-the-air rate and a higher PWM rate. Although it really, honestly, it's not necessary. It just simply is not necessary to do that. In fact, the real truth be told, you'll get longer range with this. And keep in mind, that's 100 cycles a second. So it's 100 packets a second. So, it's just not necessary. But anyway, what we did while we were troubleshooting is I took a Radio Master. I took another, I forgot which one it was. It was another Radio Master. It was an ER6 probably, or maybe even this ER8. But we plugged the servos into that. And when we did that, there we go. No twitching at all. No motion, no movement, no noise, no nothing. It's dead silent. It's not moving. I put a little pressure on there and it's pushing against the pressure, of course. But when the control surface was idle and not being moved, we got no twitching at all. Now, I'm not throwing shade against the EPW6 because I can tell you guys that I've hooked these little receivers up to at least 100 different servos. At least 100 different servos. This is the first time that I've ever encountered that issue. So I plan on talking to some smart people like Captain Bry and seeing if there's a way we can figure out what's going on here, because that to me was not acceptable. When the amount of movement that I saw on my control surfaces, I thought, no, that doesn't work for me. So what we ended up doing is we had an ER6 GV, and we used that in the tail instead, and it worked fine. As soon as we plugged that in, we didn't get any movement at all. Okay, so I did want to explain that to you guys, because if you saw the video, Dave's video, we started with an EPW6 because it was a perfect candidate to go up into the vertical stabilizer, right? It was a very, very good candidate for that, and that's what we did. So that's why it didn't stay that way. Now, I'm not going to throw these away. I'm not throwing shade at EPW6s, but I'm going to ask around and see if I can figure out what the heck is going on here. I'll see if I can figure that out. Okay, so that is it on the receivers. Now, I want to show you guys, I'm not going to go through the entire configuration because, take a look here. On the mixer, this is my mix setup on that plane. It's probably, I think, the most complex mix arrangement that I've put into production. I've done testing with stuff like this and, fine, no problem. But this is like the most complex mix arrangement I have in the whole, in a plane that I actually fly. So that's the mix setup. And then if we take a look at the logical switches, somebody asked me in Discord, and I said, I think there's about 19. That's pretty close. I think I skipped a few up here, but yeah, there's a lot of logical switches in there, and there's a handful of special functions in there too to get everything here working the way I want it to. So let's talk a little bit about some of the really cool features on this one. The first one I'm going to take you to is the brakes. And I also have to call a spade and give credit to Dave, because Dave is the one that gave me the idea for the anti-lock brakes and disabling the brake circuit when the gear are up. He said, and it makes sense. Like, let me explain why we did that. these brakes, they take up some amperage. Like when you activate the brakes, they take amperage. They put a load on the system, so they're hitting your battery, and they're heating up your BEC, and of course they're hitting the brakes. So they take up amperage. So my theory was simple. If the gear are up, if the gear are up in the belly of the plane, then why would you ever need the brakes applied? Why would you want amperage, right? So we fixed that. You know, again, Dave brought that one up. He said, "Hey man, you should not do that," right? So what I did was I created a little bit of a logic circuit, and here it is. Here's the logic circuit. So whoops. So the logic circuit is, oh shoot, I lost my spot. Here it is. Okay, the logic circuit is real simple. L07 says when A is less than X, my left slider, which is my gear, right? It says when the left slider is below 70, then L07 is on. So very simple. If it's above 70, it goes off, and if it's below that, it goes on, right? So what that means is anytime that we're not near the top, right? You remember you have 100 to 0 to negative 100. So if 100 is up here and we come down to 70, right at that point, that means the gear is starting to come down, right? So when it hits that point, then L07 goes off, because that's interesting to me. A lot of times when I'm building my logic for these setups, I say, what is the interesting thing that I want to know about, right? So I want to know when the gear are down or coming down. And that's why I do this. So logical 7 is interesting, right? Because I know then the gear are coming down. So that's case number one. And then the second case was when the throttle is less than 90, when it's less than negative 90, and when L07 is on. So in other words, when the gear are down and the throttle is off, then L08 goes on. Make sense? So if this goes up, you see how 8 goes away, all right? So when the power is off and the gear are down, that's an interesting time where I want the brakes to be allowed to be on, because my gear are down and I've turned the power off. Now, I know some of you guys who know about flight operations will say, wait a minute, then you can't do a powered takeoff, like a short field takeoff, because you can't apply the brakes, right? Because in that case, you hit the brakes and then you advance the throttle. And then once the power is all the way developed, then you let go of the brakes and it takes off. Okay, number one, I don't ever do that at the field. And number two, it'd be a simple matter to change the logic, right? I wanted to do it this way because my thought was, what if I'm on the ground and my gear are down, my throttle's off, and I decide I want to punch out? I don't want to start worrying about whether or not my brakes are on. I just want to be able to go. So my theory was real simple. If I want to use this throttle, I want the brakes turned off, full stop. So that's how I came up with this theory, right? In this method. Now, the reality is you can do it any way you want. If you want to do your own where you can do that power takeoff, the short field takeoff, go ahead. You can do that. This is the way I wanted mine, okay? So that's the theory, right? Gear down, power's off. Now the brake circuit, L08, that says, okay, it is now okay to use your brakes. So let's see how I implemented that in the radio. We look at the mixer, and we'll scroll up, and we'll look at the brake channel. And what it says is, when L08 is not active, I want the channel 7, which are my brakes, to be set at the minimum. It basically, so the weight is 100%, right? So what happens is, if L08 is not active, meaning it's not on, then I want my brakes to be set at minimum, which means they're off, okay? So what we're going to do is I'm going to put my gear up, okay? So when I put my gear up, notice what happens. Watch what happens to channel 7, right? Channel 7 is right here, and here's how I apply my brakes. So let's say I'm applying my brakes, and now I put the gear up. See what happens to my brakes? They immediately go off, right? So that's gear up, they go off, okay? Now, if the gear are down and I start advancing my throttle, look what happens to my brakes. See? They go off, right? So they go off. If I advance my throttle, brakes are turned off. Now, if I bring my throttle down to 0, now I have brakes again. You see that? Isn't that cool? So that's the logic for that. Let me go back to the mixer. We'll take one more look. So in the mixer, you have when L08 is not true, when it's not L08, then the brake circuit is active. When L08 is active, meaning the gear are up or the throttle is up, then we set the brakes to min. That's how I do that. Okay. Now the next thing that we do is in the brakes to do the setup. Now these brake controllers were a little weird. In the book is terrible. But what I ended up doing was I set a weight of 200% with an offset of -100, which means when I'm not using the stick, right? If I haven't touched the stick, I know that the brakes are off, okay? So now when I land the plane and I get on the ground, I can start advancing the stick, and right about here, right about 30% is where they get active. So now it's a brake pedal. So right at this point, from here on, I can apply more and more pressure. Now, okay, so there's my brakes, okay? We start pushing forward on the elevator stick, and we have brakes. Okay, now the anti-lock brakes. This is one of the coolest things. Again, Dave came up with this idea. I came up with the programming. He came up with the idea. So now, when the brake circuit's active, there's one more thing that we do. Let's go back. I want to go back to L09. Okay. Oops. Sorry. L09 is right here. Okay. L09 says when the elevator stick, not the input. Notice it's not the input. It's a stick. When that is greater than 95, go active. And there's an AND switch that says L08. Okay. So L08, remember, that's the interesting moment when the brake circuit is allowed to be on, right? So when the brake circuit is on and I advance the elevator stick past 95, that's an interesting point in time. It's an interesting moment. That's when I want my anti-lock brakes to kick in. So I've advanced my stick all the way pretty much to the end. L09 goes on. Now check this out. At the bottom here, when I'm using L18, I'm using the timer function with 0.1 second on and 0.1 second off. So, and L09 is active. So the timer goes on when it just goes on when L9 is activated. So when I push this stick all the way forward, look what happens. You see L18 pulsing like that? That's the anti-lock brakes. So if we look at the output monitor and look at channel 7, I can advance my brakes. So that's just normal braking right there until we get past 95%. Just like in a panic stop on a car, right? We panic stop. Now look what happens. The anti-lock brakes kick in and they go on, off, on, off, on, off every 10th of a second. Isn't that cool? That's the anti-lock brake setup on this plane. Okay, a couple of other things I thought I'd show you might find interesting. Elevator, let's see. Elevator is here. We've got elevator on 12 and 14. Remember, that's on the rear receiver. So what happens on the book, on the Avanti guide, it says when you advance your rudder all the way, it wants to see a change in your output of about 4%. So see how we have -11 here? And we go all the way to the right, it gives down elevator 4%. And it does the same thing on this one. So we're at 9%. We go all the way to the right, we go to 5. Now it does the same thing going to the left. If I go to the left, we go down to 5. And if we go left over here, we go down to 7. So that was a mix they wanted with the rudder to elevator. And then they also wanted a mix with the rudder to ailerons. And I think the ailerons, were 7%. So if I go all the way over, yeah, it's about 7%. So if you look at this one, the mix line right there is 0. So we go all the way over. And if you go all the way right on the rudder, they want left aileron at 7%. And if you go all the way left on the rudder, they want right aileron at 7%, which is right over here. So that's the rudder to elevator mix. And the way I did that, first off, I defined a logical switch. So in here, this logical switch tells me when the rudder is moved to either 90 or -90. Now, if you were just doing the elevator and always going down, you could use the absolute value function. So you could have done an absolute value of A less than X at 90, and it would have worked for just the elevator. But when you do the ailerons, you have to switch the direction. So in that case, I just used 2 different values to indicate over 90 and below 90, right? So that way, on my mix lines, what I have is we look at the aileron, and you can see there's a 7% when we have coupling. That means L16 is on, so that means we're going this direction. we add 7%, and we go this direction, we take away 7%. Okay. And then the same thing happens on the starboard aileron. That is right here. When we go right, we add 7%. On the starboard, and we go left, we take away 7%. So it works out correctly so that when I go full left rudder, then we give right aileron. And we go full right rudder, we give left aileron. All right, that's how the book says to do it. So that's what we did. And then, of course, we've got our flap to elevator mix. Let's see. The elevator, that's right there. The flap mix is right there. And the flap controls. Flap controls are there. So I don't know why that says -7. There's something else going on. I don't know what it is. But anyway, there's a flap to elevator mix in there as well. So that is it. The rest of the stuff you guys have all seen before. You've all seen my momentary switch setup. That's this one. So I'm using SJ switch here on the back. So that's that switch right there. That's a momentary switch. So that you just press that and let it go. And when I press it, I'm using an edge function. Whoops, I don't want to edit. So when I press it and let go in under half a second, L10 goes on. And then when I press it and hold it for between 1 and 2 seconds, L11 goes on. And when I do it for between 2 and 3 seconds, then, well, let's see, 1, 2, 3. Then L12 goes on. So 10, 11, 12. And then in my special functions, I do something with those logical switches right there. 10 plays my battery voltage, 11 plays my flight time, and 12 plays my T-power on my receiver. So I know what my transmission power is on Express LRS. So there are a few other little gadgets in here, mostly related to audio and whatnot, but I think you guys pretty much have the setup at that point. That's pretty much everything. Certainly all the really cool stuff, right? So yeah, definitely one of the more complex radio setups I've put into a plane. I don't really have anything that does all of this stuff. This is the only kind of model that I have that does that. All right, I'm going to check comments, and then we'll shift gears. Let's see. Props off. Hey, props off. Glad you could make it. William Tam is here. How you doing? Props off. Hit the tip jar. Thank you, man. I appreciate that. Thank you. It's nice. Your hobby, your money. That's right, man. Rambo Flight Ken says, any high-tech servo programming for the plane? Yes, we did. We absolutely did. We got the high-tech servo programmer. We connected and we sent center on all of the servos. But even after doing that, we still got in the radio. And I'll show it to you. Spirit of full disclosure. Whoops, I already passed it up here. Spirit of full disclosure. You can see the sub trim is still manipulated just a little bit on some of these. But even we did center them. But I don't know what to say, man. After centering them with the radio, we set them at 1500 US using the servo tester. And we thought we were perfectly straight up and down, but you hook a control surface up, put the radio on it, and when you do that, it seems like it just I don't know, man. Maybe Express LRS is 1500 US is slightly different than High-Tech's. I don't know, but anyway, still some minor sub trim modifications in there. So minor. But yeah, we did use the programmer to center the servos. So that is the setup, and I already covered, we'll go back to the desktop. I already kind of jumped ahead and covered the EPW6 issue, so we don't need to cover that again. And that kind of brings us to the end of the PilotJam for tonight, which is, about an hour. How about that? Right on time. No Q&A tonight. I ran out of time. I was putting Dave's 48 segments together, so I ran out of time to do a Q&A segment. We'll have to get to that next time. But yeah, man, the Avanti is pretty cool. It's a gorgeous model, and if you're interested in taking it to the next level with EDFs, take a look. You kind of have to be dedicated. I'm not gonna lie. You're gonna have to be serious about that one. And I look forward to flying it some more and getting that battery time tuned in a little bit and getting a little bit more flight time out of it, and maybe taking a look at a gyro down the road. We'll see. But I think given the fact that those are 25-mile-an-hour winds that day and the plane handled them that well, I was pretty happy with the result. So now what's up next is just to go out and fly it some more. That's it. So in terms of coming up, I've got some news for you guys. It's not great news. It's not terrible news, but it's not great news in terms of the channel. And that is that I will be taking the month of June off. I've been running this YouTube channel since 2016, 17. And, we've had ebbs and flows, we've gone up and down, up and down. But at the end of the day, my wife and I are taking a month together, and we're going to go live on the beach. We're going to go live on the beach for a month. So I won't be doing any YouTube videos. I'll be checking in on Discord, I'll still be alive, but I'm going to work during the day. I'm not leaving. I can't take a month off work yet. All right. I'm not there yet, but I can work from anywhere. So we're going to go to the beach. We're going to hang out there for a month. I'm going to work my day job from where we're staying. And in the evening times, we're going to go to the pool. We're going to go to the beach. We're going to go do some drinking. We're just going to have some fun. And we're going to do it for the entire month of June. The entire month of June. So for June, there will be nothing. RCVR as a channel will be quiet. And we'll come back in July and get back at it again. But yeah, we're going to take up some time, man. I'm going to take some time and spend it with my best friend in the world, and that's my girl, my wife. And she deserves it, man. She deserves it. She tolerates all my nonsense, all the stuff I do for work, all the stuff I do for YouTube. It's time for me to give her some time back. It's all good. Nothing bad happening. We just decided to go have some fun for a while. So we're going to do it. So anyway, that's it for June. I just wanted to make you guys aware. In May, in terms of what's coming up, we're going to be doing some, let's say, maritime ops. Let's call it that. We're going to be doing some maritime ops, and we're going to be going to Miami for an event down there. It's the Amps, I think is the name of it. They have a show down there. So we're going to go down to Miami and hang out with those guys. These are some of the guys that keep coming up to our events, like the EdgeTX, it was the RCVR Fly-In and the Torches Spring Bash. That group, they come up and hang out with us. So we're going to go down and hang out with them. We're going to get the camera out and film the event down there and have some fun. So that's the plan. So that'll happen in May, and there'll probably be some more flying, and we'll get Freddie on camera. I'll fly some helicopters some more. Oh, yeah, that's another thing on the helicopter front. I have something special in work there too. I'm not going to tell you guys what it is, but I have something very special coming up on the helicopter side too. So I'm working on that. But yeah, so for the next couple of weeks, I do not have an airframe inbound. I got to swallow the pill that was the Avanti and the and the laser, the 85-inch laser. They all came together. So anyway, yeah, what'll end up happening is May we'll just be flying. We're going to fly these planes. We're going to fly the laser, the Avanti. We'll have some fun, get some day at the field kind of videos going, and then we'll do the trip to down south. We'll do the maritime ops, and then June it'll go dark. It'll go dark for about 30 days, and I'll catch you guys on Discord. Maybe I'll post some. Maybe I'll post a couple of shorts or something. Maybe I'll take a drone down there and fly it at the beach. Who knows? But I'm gonna go relax on the beach. Let my hair grow. Maybe I'll get a tattoo. I don't know. We'll see. All right, guys, I hope you enjoyed the Pilot Jam. Thanks for your patience on the Pilot Jams. It's just been one thing after another. I'm glad we finally got a chance to get together. I hope you enjoyed the videos on the Avanti. I want to give a great big shout out to Dave, man. He was so amazing putting that plane together. He did a really, really nice job. I mean, he very thorough, took his time. He did a fantastic job with it. So big props to Dave for putting that Avanti together. And yeah, that's it. So I hope you have a fantastic evening, what's left of your weekend. I hope it's good for you. And make sure you get out there and fly something. That's all I've got for today. Take it easy.